Here. I want to again thank you for joining us, and we'll just step to our first slide here. And I want to point out that this is a live virtual class. Yes, this is a live virtual class, and this is the voice in computer. So no phone is needed. Headphones can be used to plug into your device. Everybody is going to be in listen-in mode, but this will be an interactive class. So if you have questions, there's a couple ways you can share them. You can chat it in your question box, which is on your drop-down menu for your GoToWebinar, or you can click and raise your hand, and I can unmute you and we can talk about some of the questions you have on hand. And there are going to be times planned throughout this presentation that we're going to poll questions, and I'll answer some questions as well. I did save some longer time at the end of this class that we can have a longer Q&A section. Also, there are some handouts available in your handout section. Feel free to review them, download them, print them. They're handy to use as a weather spotter. All right, so let's jump through our agenda. So we're going to talk about what the Weather Spotter program is all about. Those new to the program, you can be enlightened by it. I'll talk about what the role of the National Weather Service is and the tools that we use. Then we'll get into how weather spotters report, the weather hazards, and ways of staying safe. Then we'll touch on getting the word out and discussing other programs that are available that you can be involved as a weather enthusiast. And lastly, we'll touch on the long-range outlook. But first, let's do our first poll question. So I'm going to be launching this question for everybody, and it gives you a chance to vote and pick your top one. So our first poll question is, what is your main source of weather information? So I'll leave this up here to let you vote for probably about another 30-40 seconds. So we will have polls like this throughout our presentation here. And if there's some questions, I will try to answer them. So here's a question right now about phone apps. Well, let me tell you, we will get into that later in this conversation. Oh, how do we answer the poll? Well, there is a section that you can pull down called polls in your menu bar, and it allows you to fill in the little dot, the radio button on that. Okay. So again, the poll section is in your menu bar. It's called polls. And there we go. There we go. We have a lot of people that are answering right now. I will let this go for a couple more seconds. It's very interesting to see these results. Okay. And things look kind of quiet now, so I'm going to close this and then share the results. So here was what's very interesting is most people use phone apps to get their weather information, so on their devices. Next on the list is the National Weather Service webpage. Yay, good job. And many people use the TV or other sources. So great information. Thanks for playing along, and we'll continue to do this throughout our presentation. All right, so many of you, I believe, are current weather spotters, and I want to give you a big shout out. Thank you very much for all the hard work that you do with all the reports you phone in, send in to us. We appreciate that very much. And we know we have a core group that we can count on for reports, especially in Spokane County. In fact, they come and join us every December. There are Aries Races group in Spokane County, and that's what some of these pictures are. These CAM people are countless weather spotters that come in and spend time with us and gather reports, especially on Skywarn Appreciation Day. So I want to give you a big shout out. Thank you. But to those of you new to the program, you're probably wondering, what is a weather spotter? So a weather spotter is a person that's interested in weather who volunteers their time to report severe and hazardous weather. And being a weather spotter is really easy. There's no equipment needed. It's on an as-needed basis. And you simply call, email, or send reports online. And through this training, we will give you the knowledge of what you need and what to look for to report severe weather. So if you're interested, please stay tuned and we will cover more. So the National Weather Service. Well, we have weather service offices all across the country, and part of the federal government under the Department of Commerce, and then within the Department of NOAA, so the National Oceanic and Atmospheric Administration. The National Weather Service is responsible for all weather and water watches and warnings across the country. And as I said, we have offices all across the country, 126 total offices. As the National Weather Service, we work with local agencies. We work behind the scenes to observe the weather and provide the forecasts. And we also provide decision support for many of the counties and emergency managers in our area. We also provide preparedness and education as well. And here is a picture of our office in Spokane. Lots of monitors on the wall, on the desks, and we have a full office in this picture that is busy monitoring the weather. So our office is located west of Spokane, actually west of Airway Heights and north of Fairchild Air Force Base. We are staffed 24/7. We have people there even now, even though things have shrunk under these circumstances we are dealing with right now. But we have people there 24 hours a day, 7 days a week. And this office has been open at this site since 1995. We have 21 employees, most of which are meteorologists, but we do have our technicians that are available to keep our systems running smoothly. The main duties that we have involve observations, especially the weather balloon, the forecasts, which cover not only public forecasts, but aviation forecasts and fire weather forecasts, and then most importantly, our weather watches and warning program. And we have a very robust public service unit that answers the phone calls, answers your emails, and keeps the information flowing. So we have a distinct area of responsibility for our forecasts and warnings, and it is quite diverse, spanning much of eastern Washington and North Idaho. So it runs from the northern Cascades all the way to the Montana border, and from the British Columbia border just north of the Tri-Cities. And our main weather concerns change with the seasons, and they include winter storms, which we are concerned with snow, ice, rain, and wind. Flooding in the springtime into the summer with river flooding and flash flooding. Fire weather in our summer and fall time where we're concerned about wind and dryness along with lightning. And then thunderstorm season, which we see in the springtime and summertime, and our concerns range from hail, wind, rain, and lightning. So here's a map of the counties that is in our area of responsibility. And we have quite many of them across eastern Washington and North Idaho. One thing that we do divide this area up is not only by the county, but you'll hear the term zone. We have zones as these areas are divided up by the climatology, the elevation of the area. So they match somewhat of the counties, but they're a little bit different. And the reason why we divide this area out to provide a better forecast. And one example that I'd like to use is just by looking at the topography of our area. We have the mountains, the Cascades that bisect Washington. We have our mountains to the north and to our east in Idaho. And if you think how our weather systems come, they move mostly from west to east, bringing a lot of that Pacific moisture across the area. And just by looking at this terrain, we can also look at the annual average precipitation across the region, and we can see distinct areas or climates that develop. We have the heavy precipitation along the Cascade Crest. We have the low amounts of precipitation across the basin, the Columbia Basin, and then the precipitation increases again across the mountains in Northeast Washington and North Idaho. So our zones, our forecasts are based on the climatology of these areas. So the National Weather Service uses many tools to observe the weather in the atmosphere. And right in our office, we use weather balloons, we have the radar, and we use weather satellites. So weather balloons are launched from the office in Spokane twice a day, every day. Right now, they go up at 4 a.m. and 4 p.m. daily. And they consist of a giant balloon with a long string that is attached to a sensor that takes measurements of temperature, humidity, wind, and air pressure. And as it's attached to that balloon, we just let it go and it floats through the atmosphere. And you probably wonder how high it goes. Well, it goes through all the different layers of the atmosphere, past to where airplanes fly, up to the edge of space. So a few facts about our weather balloons. As I said, they're launched twice a day, every day. There are about 92 upper air sites that launch weather balloons across the country. Each one travels about 100,000 feet high, so roughly 19 miles high. Each launch lasts about an hour and a half to an hour and 45 minutes. With the balloon and the Radiosonde sensor that's hooked to it, also is included is a parachute. So as the balloon rises up through the atmosphere, the balloon gets bigger and bigger and bigger until it finally pops. And when it does, the parachute will open up and allow that sensor to come back down to the earth. We receive less than 20% recovered back, and they are mailed back so they can be refurbished and used again. But the data we get from these sensors is very important. And it looks like a chart like I show here that indicates what the winds are doing through the profile of the atmosphere. It shows traces of what the temperature is doing along with the dew point, or the measure of the moisture in the atmosphere. And you can find this information, this chart, on our webpage, and it's located on our Forecast tab under Forecast Models. Another useful tool that we use are weather satellites, and there are many channels that we can look at and examine the atmosphere. So a weather satellite is launched by a rocket and put into space to orbit the Earth. The type of satellite we use most often is a geostationary satellite, which remains parked over a part of the Earth looking down at the atmosphere. And the one that we use in the western United States is called GOES West, or geostationary west. And the most used channels that we look at include the infrared that shows the temperatures of the clouds, the water vapor that shows how much moisture is in the profile of the atmosphere and lets us know where the storms are with a lot of moisture, and then the visible image, which looks like a giant camera looking down at the atmosphere. So these weather satellites pictures come from the GOES 17, or the GOES West. And this satellite was launched just in 2018, and it shows crisp, high-resolution pictures. There are 16 different channels to look at with this weather satellite, and we get new images about every 5 minutes. And with this early detection, we can be able to see thunderstorms as they're developing. We're able to spot hot spots where possible wildfires are, and we can also see fog forming in valleys and in the coastal areas. And you can find some of these weather satellite images right on our webpage. You just look under the Current Conditions tab under Satellite. A Doppler weather radar, very important tool, and we have one right at our weather office. It's been there since 1995, and here are some images that show our radar. One of picture shows how we maintain it and paint the dome. It looks like a giant soccer ball on stilts. Just last summer, we had new parts in a pedestal replaced inside the dome, that we had a large crane come and take the dome off to replace the parts. And there's another image that shows the size of the dish of the radar, which spans about 30 feet in diameter. So the radar works pretty fascinating. In this dish, it emits an electromagnetic charge that goes out through the dish and sends a signal out into the atmosphere. This is called the pulse. It listens for a return signal where it bounces off of a raindrop, a snowflake, some hydrometeor in the atmosphere, and then it sends the message back to the dish. As it does, the dish is rotating in a circle and does a slice of the atmosphere. Once it finishes one slice, it goes up about a half a degree and continues this process again through multiple slices at higher elevations. A complete scan of all the different elevations takes anywhere from 4 to 8 minutes, depending on how fast we want the radar to rotate. Our weather radar is a very important tool, but it does have its limitations. As storms move farther away from the radar, it seems to miss the lower sections of that storm. And that's because our starting elevation we use is a 0.5 degree. So as the storms are tracking farther away, we seem to miss the lower sections of the storms. Also, we may get some beam blockage due to mountains and terrain in the way. Another important tool that we use are surface observations and web cameras. Surface observations are automated in most locations and are located at area airports, but we also have partner agencies that have set up these automated sensors along highways, thanks to the DOT, and the Forest Service that has them in the forests as well. So we can get hourly data, sometimes every few minutes, data of temperature, of precipitation, of winds, of air pressure. But one thing these automated sensors do lack is they are unable to tell us snow depth at a location. If there is a thunderstorm, we don't get measurements of hail size, we don't get measurement of any images of wind damage, and it's not able to report tornadoes or funnel clouds. So we need that human interaction to help us out. Web cameras. We have quite a network of web cameras that can be very useful, especially during times of changing precipitation from rain to snow, and also when we see thunderstorms moving into an area. With these web cameras, though, they are along busy stretches of highways or at airports that we see a lot of people at. So they can only be used where areas that we see a lot of traffic. We also have our network of supercomputers that produce our weather models. All of this weather balloon data, the surface observations, the radar data is funneled into these supercomputers that help us process weather models, high-resolution models that can give us updated forecast data, sometimes every hour to 6 hours. So you're probably wondering why we need weather spotters. Well, they are an important piece to the puzzle. Due to the current limitations to the radar and not seeing full storms at great distances, we need to get that human report. Sometimes there's events that are happening that we can see on radar or satellite, but we need to know what the ground truth is of what's happening at the surface. And sometimes we have areas that we have holes that we have our observations spaced so far apart that we need a report happening in a certain location. And our main goal is to maximize our warning effectiveness and increase our lead times on severe and significant weather. All right, so we are going to go to our next poll question. And as I said, this is a section in your menu tab under polls. And we're going to go to number 2 and let you answer the question. What is the primary mission of the National Weather Service? And also, if you have any questions you want to type in, I can answer them if you'd like. One was, what is the furthest away a balloon has landed? Well, we've received some of them from Montana, from Idaho, but also I wanted to say that we have received a returned radiosonde that was written in Japanese. And we were thinking, whoa, that was quite the jet stream that brought it over. And we were looking back to see what the wind speeds were doing, if that could even happen. Then we realized in Moses Lake, Washington, they have a large airport, and Japan Air runs test flights there, and they had dropped a radiosonde out of one of their planes there. So actually, it didn't come that far away from us. So lots of great questions, and I see we have lots of people voting right now. Just give it just a couple more seconds. There we go. Oh, very interesting. Okay. All right, we're going to end it, and let's share the results here. Very interesting. So it looks like the majority of the people got it. The main mission of the National Weather Service is to protect lives and property with weather hazard information, or issuing the watches and warnings. Second will be issuing the forecasts. So great job. Thanks for taking part in this. And we will go on to the next question. The next part of our presentation. As weather spotters, there is a checklist that we have put together on severe and significant weather conditions that we would like weather spotters to let us know on. And it is designed, this checklist is designed in kind of a very colorful pattern, with the top one being the most severe significant weather being tornadoes or funnel clouds. Then we go down to strong winds and hail, heavy rain, flooding of any kind, mixed precipitation, including freezing rain or sleet, snow, especially significant amounts through the winter time, poor visibility, due to fog, smoke, blowing dust, any type of travel problems due to weather, any damage, injury, or loss of life due to weather, and any excessive heat or cold. So this checklist is available in your handouts that you are welcome to download and keep a copy of. So as weather spotters, the easiest way to report significant or severe weather is to give us a call. And we've have a toll-free number, easy to dial, set up just for weather spotters, 1-800-483-4532. It is our spotter line. And with that, when you call this number, you'll reach a person any time of the day or night who will be there to answer that number. And when you do, please give them your spotter ID. You're probably wondering, what is a spotter ID? Well, when you finish this training and we get you registered as a weather spotter, you will receive your spotter ID that you can use when you call in future reports. So when you do call and give a report, you want to give the message of what was the event you saw, where you are, the location, and what time was the event. So it's pretty easy. Just another easy way to send reports is online. On our webpage at weather.gov/Spokane, you can scroll down to the bottom of the page and we have a collection of widgets that you can click on and go straight to that information. And one is called Submit a Storm Report. And when you click on that, you will get a GUI that pops up that allows you to enter your storm report and submit it, and it will alarm right on our workstations in our weather office. So it's pretty slick. But there are other ways to share the weather data. One of them is social media. We have accounts set up on Twitter and Facebook, and you can share your reports on these platforms, especially the pictures. And for those of you that are Facebook fans, I am so sorry that we have been offline for the last couple of weeks, but good news is our admin issues have been fixed and our Facebook is back. So you will be seeing more posts from us in the future on this. But we monitor both Twitter and Facebook, and we appreciate the reports and pictures sent through social media. Another great way of sharing weather data is through a link and app called mPING. And this uses crowdsourcing to gather reports of precipitation type, of flooding, of any type of damage. It's completely anonymous and very easy to use. And you can look for this app on your phone, works on both iPhone and Android, and allows you just to report, is it raining or is it snowing? Or is it freezing rain? So the different types of precipitation type that allows us as forecasters, we get these reports and it will show up on our radar screen and allow us to determine what the precipitation is. Another handy email to hang on to is our office email, and it's a great place to send your weather photos. Email your photos of the different types of weather reports that you see in your area, spanning from wind damage to hail to flooding. We love to see these weather pictures. So what is in a spotter report? Well, specifics are to tell us the story. We want to know who you are, what you see, and where you are. So spotter ID is important along with your location, what city you're in. Tell us the time, when it began, when it ended. You can give estimates of wind speeds or hail size, and also include any reports of damage or injuries. If you're unsure of what you're seeing, let us know your uncertainty. Like you may think you're seeing a funnel cloud in the sky, but you're not sure. That lets us know to examine things a little better. Also include reports while traveling and any delayed reports. So if something happened last night, you can call us the next morning and let us know. As long as you know what time it was, we can look back and verify the report. So here is an example of a good spotter report. This is Tom Smith, spotter Spokane number 25, calling from my home on South Hill. There is currently large hail falling, and I measured one stone, and it's about the size of a quarter, and it began about 30 minutes ago. This is a good spotter report. Thumbs up to Tom on this. Here is an example of another good spotter report. This is Bob Smith, Bonner number 38. I'm currently driving along Highway 95 near Sagal. I see lots of standing water on the roadway and in the ditches. It looks like a mudslide. A car slid off the road and it's pouring out. I'll email you a photo when I get back home. Again, a very good report, including location, the time of the day while he's driving. He will send the report when he gets back home. So very good information. Well, here's a report that is not so good and may need a little improvement. Hi there, how you doing? Who is this? Oh, hi, Steve. This is a spotter in Ferry County. I see lightning to the north and it's raining here a little bit ago. The news says it's much worse to the south. Are we going to get another thunderstorm? How long is it supposed to last? How's your evening going? Well, this spotter report needs a little bit of improvement. What are some ideas that you would suggest to improve this report? Well, one is to identify yourself with your spotter ID, maybe your location, giving you the forecaster an idea where you're calling from would be very important. Maybe a time of when the lightning occurred, what direction it was. Was it frequent? Was it just one or two strikes? And maybe something else on the spotter checklist. It's really important to make sure that you're identifying something that is on the spotter checklist. Also, keep in mind that we may contact you as a registered weather spotter. You'll share your phone number with us, with the National Weather Service. And if we see severe or hazardous weather near your location, we will likely try to call you to get more information or ground truth on what is seen on radar. So this example, this forecaster is tracking a storm, and plotted on our radar map, we'll have this spotter location and the spotter ID. And with that, we can call you as a spotter and verify there is a storm that moved through your area and find out what type of reports came from that storm. Emails are important as well. Besides the phone number, it's important to keep emails current, because in cases where there is going to be a widespread severe weather event or thunderstorm risk, we may email you to let you know so you can be alert on the changing weather. In addition, we send periodic emails to you to release our quarterly newsletter and let you know of upcoming training opportunities. As for thunderstorm outbreaks, we do get them. In fact, just back in 2016, we had a day that had thunderstorms that went all across our region, and we had reports of flooding, to tree damage, to hail, and even tornadoes in our area. All right, our next poll question, number 3. And we will launch this one. All right, the poll is open. What is not necessary to include in a spotter report? So we have some information on here, and we're going to let you answer those questions. I'm going to check my list to see if there's any questions that were recently submitted. Okay. Why can the cameras only be used on busy roads? Oh, the web cameras. Well, they're with our partner agencies like the DOT and some of the local airports. And where they put them is how we use them. So that's why we just use what our partners have available to us. Another question. How does aviation avoid weather balloons? Good question. Well, we do call the tower at the Spokane airport 5 minutes before we're going to launch a weather balloon to make sure there's clearance that no planes are flying around our area. Plus, also at the Fairchild Air Force Base, they know what time our balloons go up and avoid any air traffic around that area. Another question, where would grapple fit on the checklist? Yes, grapple. Well, we're going to touch on that a little bit. We describe grapple as soft hail. We get that typically in the late winter, early springtime when our clouds are still mostly icy. And I would call that a hail report, and feel free to include that as well. Can you define excessive heat or cold? Well, when we have wind chill conditions out, that would be some excessive cold, and heat, there's any type of a heat risk out there, that would be excessive heat, and I will touch on that later on, probably at the end of our presentation. So thank you for all those questions. All right. I see our poll is quieted down, so let me close it and share the results with you. So the top winner was 83% something not on the checklist. Correct. The other points would be important to include in a spotter report. Where you are, what you see. You can include events that happened, delay, like the day before, if you give the time that they happened, but try to stick with things that are on the checklist. Okay. All right, so great job on that. And we will get back to our presentation. So hopefully you had time to stretch a little bit, because we're going to get into some exciting weather. Be our thunderstorm hazards. Since we're in the springtime, moving into our warm season, thunderstorms are going to be our main type of hazard that we are going to contend with. So for thunderstorms, it's important to understand that we have 3 main ingredients for them. And it includes adequate moisture in the atmosphere, enough instability to cause air parcels to rise, and a lifting mechanism that's going to force that air higher in the atmosphere. So our first ingredient is moisture, and that is something that sometimes we lack a lot for strong thunderstorm development. Most of our moisture comes from the south, coming from the Pacific, maybe even further to the south and east, but it takes a while to get to our area because it has a lot of terrain to cover to get into the inland Northwest. The second ingredient includes instability, and that's describing how the air particles will react in the atmosphere. A stable environment, well, let's back up. Both types of air, warm and cold, have different densities. Cold air tends to be heavier and likes to sink. Warm air is lighter, less dense, and likes to rise. So when you have a setup that you have cold air near the surface, warm air above, it is considered a stable environment, and the air will not want to mix at all. Typically, we see this in the winter time, especially on those cloudy, foggy days when we have cold air in the valleys and warm air above. So at the mountaintops, they're in the sun. So what we want for an unstable atmosphere is the reverse. We want to have the warm air at the surface heating up with cold air aloft. So this setup will allow the air to mix and rotate. And this mixing of the air causes cumulus clouds to develop and the air particles to rise and form and develop into bigger clouds. So we need that instability in the atmosphere. The third ingredient is the lifting mechanism, and we can get them from a couple different forms. One common form is with a cold front. Think of a cold front as a big cloud that's moving through an area of cold air that pushes and forces the warm air aloft. This colder, dense air moves into an area and forces warm air up to form clouds, cumulus clouds, and then into thunderstorms. The air converges along this boundary and is forced to rise. So this is a very common lifting mechanism, and usually with cold fronts, we see drastic changes in the weather, whether we get showers, thunderstorms, wind switches, temperature gradients. Another lifting mechanism is just from upslope flow or lift from the mountains, where we get a prevailing wind hitting one side of the mountain, the windward side, forcing air up the terrain to the mountain peak, and then the air sliding back down on the other side. So we will see clouds forming on the windward side of the mountain, and then the leeward side is more of the drying and warming of the air. And we will see precipitation falling depending on which way the wind direction is blowing from. So we see this quite a bit on a day which is unstable. We'll see the clouds forming over the mountaintops and showers and thunderstorms then developing at the ridges. So this is something that we see quite a bit on a spring, early summer day. So for thunderstorms, we have three distinct stages for a general thunderstorm. The first one is called the towering cumulus stage, and this is where you get your puffy cumulus cloud that starts to develop and grow and starting to rise through the atmosphere. So most times just starting to get above that freezing level. As it does and continues to develop, it will move into the mature stage. And that's where we have the updraft, fully supported and rising up through the atmosphere, pushing that cloud up to the upper portions of the atmosphere. At the same time, the downdraft develops and pulls some of this rain-cooled air and precipitation down to the surface. So at this mature stage, this is where you're going to see your maximum cloud height. You're going to see your downdraft with your precipitation and gusty winds and hail with this. But with general types of thunderstorms that go straight up and come straight down, that downdraft will then eat away and start the dissipating stage of the thunderstorm. And that is when the updraft gets wiped out and it's just a storm that's raining out. So you'll get your precipitation continuing, the gusty winds, and then the hail slowly dissipating through that. The lifespan of your typical garden variety thunderstorms is about 20 to 30 minutes. And sometimes you'll get regeneration of these down the line. So you'll see this pattern developing. So getting reports from this type of thunderstorm is very quick. You'll probably get a burst of time where you'll get severe winds and hail that last a few minutes and heavy downpours, and then the storm begins to decay. Here's a picture from one of our weather spotters sent in last year that shows this terrific thunderstorm in the distance. You can see the lightning and the flashes. So here I want to identify the updraft and downdraft of the storm. The updraft, you will see the rain-free base, where you can see the clouds, edges, and you can visualize the air rising up through the thunderstorm. The downdraft would be on the other side, where you see the rain shaft and the wind coming down. And this type of thunderstorm would be your garden variety thunderstorm, lasting probably about 30 minutes. So what makes a thunderstorm severe? Well, there are two criteria that makes a severe thunderstorm. One is winds of 58 miles an hour or greater, or hail 1 inch in diameter or greater. And 58 miles an hour, if you convert it to knots, is 50 knots. So winds of this speed are able to produce significant wind damage with trees and structures and buildings. And hail that is 1 inch in diameter is actually the size of a quarter or larger. And this is a standard criteria all across the country. All right, so now we're going to get to our next poll question. Also a time to stretch if you need. Okay, let's get to this. Okay, launch right here. Okay, the poll is now open. How strong are severe winds? Okay, hopefully this isn't a tricky question, but pick your best answer. And I'll see if there's any other questions that have come in. Okay. So I had a report from somebody, a question that somebody that sees fog every day with low visibilities. Do you really want a report every day on fog? Well, if it's a continual pattern, probably not every day. But if it's significant, maybe it's freezing fog, or maybe there's an accident associated with that, then yes, we would want to know reports on that. Another question, what are the degree parameters for excess heat and cold? Okay, that is a good question, and I don't have that right off the top of my head, but I will get that information out to you with at the end of the class, or maybe in a email later on. But typically, I think for excessive heat, we want things that are 90 degrees or warmer. And for excessive cold, I'm thinking that it'll probably be below 0, but I will have to fine tune and find that information for you. Okay, other questions? Are supercomputers local? Well, the biggest area of supercomputers are actually in our National Center in Washington, D.C. We do have some very high-powered computers in our office that are used to run some of the local models. Okay, another question. Is the downdraft side of a storm normally on the side where the wind is coming from? All right, the downdraft side of the storm depends on the track of the storm. So typically you will have the air feeding into the storm on the front side and the downdraft coming down on the rear side. And if it is tracking, let's say west to east, then yes, it would probably be on the southwestern flank of the storm. Okay, let's see. We are going to close up our poll and let's share those results. Now, I said this might be a bit tricky. How strong are severe winds? Okay, so as I mentioned, severe winds are 58 miles an hour or greater. So winds of 65 miles an hour would be considered severe. 55 is just a hair shy of that. So yeah, sorry for making that one a tricky one, but 58 miles an hour or greater. So closer to 60 miles an hour would be severe winds. Okay, great job though. Let's get on to our next section. Hope you got a little stretch in. All right, so we have a forecaster in our office that has been looking at severe weather for the inland Northwest and compiling the climatology for our region, going back to 1950 and looking at the number of reports of severe thunderstorm winds, severe hail, and tornadoes across our region. And it is fascinating to see the reports over the last several decades. We see most of our reports come as severe winds or wind damage. Those are the ones in orange. We do get quite a bit of severe hail reports and not so much in the way of tornadoes. We also see some of our most active years recently included 2012 and 2014, which were some busy years, along with 1997. And also want to keep in mind our radar was officially turned on in 1995. So if you look at anything before that, the reports seem very limited. Also want to point out that also before 1995, the forecast responsibility was actually shared with either the Seattle office for those in Washington and the Boise office for those in North Idaho. So it wasn't until the Spokane office was spinning up that they took over control of the severe weather program. All right, here is another interesting graph that shows local severe weather climatology by month. And what we find out with is the peak month for damaging winds and hail tends to be in July. That's when we see most of our reports. But the peak month that we see for tornadoes tends to be in May, so earlier in the summer. I also want to point out that we've had severe reports both in November and January. So even in the late fall and winter time, we can get severe reports. And here's a table that shows severe weather by time of the day, and it's not surprising. Most of our reports come from mid-afternoon to mid-evening, so somewhere from 3 o'clock to 8 p.m. It's less active during the morning hours, but we still get wind reports overnight into the early morning hours. So sometimes we'll get some convection that moves up maybe from Oregon that will start developing strong wind gusts that will continue past midnight. All right, so we're going to jump into more complex thunderstorms. This would be called our supercells, not your ordinary thunderstorms. These types of thunderstorms have a longevity to them, and they are spinning storms that allows them to last for quite a bit longer and produce much more severe weather. So for supercell thunderstorms, they are rotating storms. And the question you may be thinking is, what makes them rotate? Why are they different than regular thunderstorms? And it has to do a lot with the wind shear in the atmosphere. And wind shear has to do with the changing of wind speed and wind direction with height in the atmosphere. So when we see winds increasing and changing with direction in the atmosphere, some directions make it more ideal for rotating storms. And we get this wind shear developing that will cause horizontal rolls in the atmosphere and cause a horizontal spinning. And all you need is one of those horizontal rolls to take place beneath a strong storm's updraft to tilt this into the vertical and cause a rotating updraft. And when the conditions are right, these setups can develop, especially when the atmosphere is quite unstable with a lot of moisture, and we can get strong to severe thunderstorms. Here's a diagram that shows a supercell thunderstorm, and you can see some of the similar things that we talked about with a thunderstorm. You have the updraft area in the rain-free base. You have the downdraft coming down where we see the rain and the hail. But in between that interface is where you see the mesocyclone. The mesocyclone is the heart of the storm that causes it to rotate. And at that interface, if you look below, in between the updraft and the downdraft, is where you're going to be seeing a lowering of the cloud base of the mesocyclone, and that's where the wall cloud would be. And within the wall cloud is where you would get tornadoes to develop. But other important features of supercells, they are large thunderstorms. They go up miles high in the atmosphere. They will have a large anvil or top of the thunderstorm, this cloud shield of cirrus clouds that spreads across the sky. And on top, the stronger thunderstorms are going to have an overshooting top, which looks like a little cauliflower bud on top of the storm that shows that it is punching through the atmosphere, the stable layers of the stratosphere. Here's another image of a supercell thunderstorm. Just a reminder, thunderstorm is also a cumulonimbus cloud. Also, these cumulonimbus clouds have quite the shield of the anvil, as you can see in this image with the overshooting top on top. There'll also be some developing cumulus or towering cumulus alongside with the flanking line, and that's the area of the updraft of the storm. And you can see the downdraft is where the rain and hail and the wind would be coming from as well. And that interface between the updraft and the downdraft is where the wall cloud would be developing and then the tornado. Here are different types of cloud types and their names. So I'm sure many of you know what the cumulus cloud look like. It's the clouds that form on unstable, warm spring, summer-like days. When the conditions are right and instability is high, we can get those developing into the towering cumulus stage. So that would be your first stage of a thunderstorm development. Other cloud types, sometimes you will see some ragged clouds underneath these towering cumulus clouds. And you might be wondering, wow, is that a funnel? Is that a tornado? But if it looks ragged and fragmented, it would not be a funnel developing. Funnels tend to be quite smooth because they're spinning rapidly. If you see any type of fragmented cloud, it's considered a scud cloud. When you see low clouds hugging the mountains that look flat, those are more stable clouds and they're known as stratus clouds. Those would not be clouds that you would be looking for any type of funnel or tornado development. But here's a picture of a wall cloud close up. It does look like there's some fragmented pieces on the edges, but if you would watch the cloud over time and if you see some movement or rotation with it, it definitely needs more examination and needs to be watched. So as we pointed out, we do get tornadoes in the inland Northwest. Not as many as other parts of the country. Our typical tornadoes last less than 5 minutes. Their track is they're about 100 yards in diameter. Their track is quite a bit less than a mile long. And our winds probably range in between 85 to 115 miles per hour. And here are some images of tornadoes across our region that we have seen in the last several years. So tornadoes are measured on their damage of what is left behind. And this is based off the Enhanced Fujita Scale. And it ranges from an EF0 all the way to an EF5. Typically, we see tornadoes in our area on the low range, anywhere from a 0 to a 1. And I think maybe we've had a 2 across Washington or Idaho, but it doesn't happen very often. I also want to point out the map that shows the average annual number of tornadoes per state. And you can see a glaring area of where the tornado alley would be, stretching up from Texas up to Oklahoma and Kansas and even parts of Nebraska. And you can see why in the West, while the numbers compare, and Washington sees an average about 2 a year, while Idaho sees an average about 5. So some people wonder, are funnel clouds tornadoes? Well, the funnel cloud is the first step of the tornado. It would be the rotating column coming from the base of the thunderstorm. Funnel clouds typically stay aloft. If you want to see if it is turning into a tornado, you need to look down at the surface and check for debris. So these are some tricky examples that we are seeing. Here is one example. You can see that well-defined funnel. You can see how smooth it is. While it looks a little ragged at the top, the funnel is quite smooth. Here's another example. You can see that lowering cloud base that looks quite large, and see that little funnel coming down, quite thin and narrow. Here is another example of a funnel coming down. And in this case, we don't really see any debris coming from this. So we want to assume that this is a funnel unless we see something a little different. And here's another example. This one has a smooth funnel with it. You can see the lowering of the cloud base with that. Definitely needs to be watched to see if there was any cloud dust coming from any debris cloud. So here's some video footage from several years ago of a funnel cloud that did produce a debris cloud. So in essence, it was a tornado. You see this example, you can see that the smooth funnel from the cloud, the thunderstorm, and you can see the debris cloud kicking up and a lot of dust and dirt. Now it doesn't quite fill in. Sometimes they don't fill in all the way to the top. So it's important to keep your eye both up in the cloud and down at the surface to look for rotation, to look for that debris cloud. Luckily, this funnel did not cause any significant damage. It stayed in the field and kicked up a lot of dust and dirt. All right, so we're going to go to the next poll question. Okay, we're going to launch this one and we're going to test your knowledge. What cloud formation is associated with a tornado? Let's see if you were paying attention with those tornado pictures. And let's see if there's been any more questions. Oh, nothing yet. So one question is, what causes an anvil head? Well, the anvil head is the top of the thunderstorm. And as the thunderstorm is building and pushing up through the atmosphere, it's spreading out with time and as it moves to the top of the troposphere. Between the troposphere and the stratosphere is a bit of an inversion, and it takes some force to push through it. So that's why we see that spreading out on the top. And areas where it's strong enough, it can push through and form the overshooting top on top of the thunderstorm. Oh, here's another good question. How do dirt devils differ from funnel clouds? We do see our share of dirt devils, dust devils around our area. Anytime we travel from Spokane to the west side and back again, we see these on a warm, sunny day. What makes them different is dirt devils get their energy from the surface, from the heating of the ground that forms those horizontal rolls that tilt in the vertical and form the rotation near the surface. They don't have the support of a thunderstorm above, so they remain weaker and stay hugging to the ground. With a funnel cloud, you have it forming from the thunderstorm itself. The energy is coming from the cumulonimbus cloud as it's rotating and sending that energy down to the surface. So that's why funnel clouds that turn into tornadoes tend to be a lot stronger, have a lot more energy than dirt and dust devils. So very good questions with that. Okay, I see our poll. Oh, I see lots of good responses. So we're going to close it and share the results. So we have a majority of people saying the cloud formation associated with a tornado is called a wall cloud. So great job. Keep in mind, stratus clouds are very stable clouds, and we see them on winter cold days, even more like a day like today in some areas. And scud clouds tend to be very fragmented clouds, and we would not see tornadoes coming from those. Okay, so we are going to move on. Hopefully, we'll go on to the next section after your stretch you had. And we're going to talk more about gusty winds. Sometimes we get thunderstorms that produce straight line winds. They're known as microbursts, or a pool of rain-cooled air that drops down from the thunderstorm in strong downdrafts and produces strong and damaging winds. This is caused by the evaporation in the thunderstorm that causes the air to become very dense. And this air wants to sink down and drop to the ground and spread in many directions. This is a great image that shows a microburst of this rain-cooled air dropping down to the surface. Sometimes we can see them from looking down from the sky, and I can tell you that these straight line winds are quite a hazard with anybody flying a plane. In fact, plane pilots want to stay away from any type of thunderstorms in the area, just for this reason alone. With these strong winds, you can see the clouds near the surface spreading out in a bit of an arc. And you can just imagine that this downdraft dropped down, hit the ground, and spread in all directions, causing these winds to spread out. And sometimes when we go out on damage surveys to see wind damage, we look for these signs. Does it look like it was a straight line winds where a downdraft dropped down and caused the trees to break in all directions? Or maybe was it a tornado and we see trees that are twisted and pulled down in a line or in a path caused by a tornado? So we get our share of strong and damaging winds. We like to hear from weather spotters any type of winds that are estimated to be over 40 miles an hour or greater, or any type of wind damage, from trees to trampolines that take flight. But keep in mind that severe or high winds is 58 miles an hour or greater. Now, for those of you that think that you need to have an anemometer or a weather station to tell you what the wind speed is, not to worry. There are charts available to estimate winds. Here's one called the Beaufort Wind Scale. It gives a great way to estimate what the wind speeds are doing by watching nearby trees or flags on flagpoles, and you can give an estimate of the wind speed. And I have included one of those in your handouts that you can download and print and have for your very own. Another type of weather that thunderstorms produce is hail. Hail develops in strong updrafts that keep these chunks of ice aloft, allowing it to circulate through a thunderstorm and getting another layer of ice that collects and freezes. One thing we have found out is the stronger the thunderstorm, the larger the hail, because that updraft is allowed to keep the hailstone rotating through the thunderstorm for a longer period of time. And when the hailstone gets too heavy is when it falls from the thunderstorm. And sometimes they can fall to the ground at over 100 miles an hour. Here is a picture we see from a weather spotter just last summer of hail from Medellin. This was back on July 8th. And he had a pile of hail coming down off the side of his house. Sometimes not only are we concerned with the diameter of the hailstone, but the amount of hail that falls that covers the ground. Maybe it's a few inches deep, as in this example. But overall, we would like a measurement of the diameter of the largest hailstone. And keep in mind, 1 inch in diameter or greater is considered severe hail. We also like to get reports of heavy rain. We would like reports of heavy downpours from a thunderstorm to even long periods of rain. So for a thunderstorm event, if you get rainfall that amounts to up to 1/2 inch in 1 hour, that's considered heavy rain, and we would like to hear a report of that. Or if it's a long duration rain event, that you get about 1 inch in 12 hours or 1.5 inches to 2 inches over a day, we would like to get that report. Just keep in mind, anytime we get rain that comes down too hard, too fast, it can lead to issues. And the main one is flooding. Flash flooding happens when we get flooding that happens in less than 6 hours or less. So that's where the flash comes from in the flooding. And typically this happens with thunderstorm events when we get very heavy rain that happens, especially on steep slopes, and the water has no place to go but to flow downhill into the lowland areas. And sometimes flash flooding can happen very quickly, flood a highway, flood a roadway, and the biggest hazard are people getting trapped in their cars during a flood event. I also included a picture of a flood event that happened at the Williams Flat Fire area just last August. That was one of our bigger fire areas last summer, and they had a thunderstorm that set up over them just that helped put out a lot of the fire, but it also caused quite a bit of flooding in this area. Here I have a video of some flooding taking place. Quite a lot of water moving through this area that I think was just a little creek. But with flash flooding, you have to be alert to this, that you can get a rapid rise of water moving at quite a clip. It only takes 6 inches of water flowing at that speed to knock a person over and wash him downstream. The water is a foot or more. It can cause a vehicle to rise up off the pavement and float it downstream, and a person can become trapped in this flow of water. So flooding is something you want to stay away from, and I wouldn't want to try driving across that at all. Sometimes we get flooding that takes a longer time to develop. A lot of times this happens with our rising waters on our rivers in the springtime and in the wintertime as well. Our river flooding, our streams and low-lying areas that can slowly creep into streets and walkways and sidewalks. Just keep in mind that you want to stay away from rising waters. I know last year we had our share of flooding, especially urban flooding in Pullman, in Moscow, in Wenatchee, in Spokane, in Kamei. We had lots of reports of flooding in these downtown areas that caused some significant damage. Along with a lot of rainfall and flooding, we can get mud and debris flows. This is when we get the water saturating the ground, causing the rock and mud and debris to move down sloped areas, especially in mountainous areas where there's steep slopes. We can get this debris to move down and cause quite a bit of damage on roadways, covering roadways with rock and dirt. Some areas are very susceptible to these types of debris flows, especially the post-fire floods. So areas that have seen burns and wildfires recently are very susceptible to this type of flooding and debris flows and rock slides. In fact, we had some flooding just last summer in Wenatchee that caused some debris flows and rocks on the highways. And this was upstream of an area that had fires more than 5 years ago. So some areas, it takes a long time for the habitat to recover after a fire. It may take years. So we just need to be cognizant of that and keep an eye on where these wildfires have happened over the last few years and keep track of how the precipitation is falling and any types of significant hazards that it could cause. Another concern that we have from thunderstorms are those strong winds that kick up the dust and dirt, causing our dust storms. Some of these pictures were caused by outflows from strong thunderstorms, or we can get the winds just synoptically driven winds from low pressure systems that can kick up dust and dirt and lower visibilities down to a mile or less. Just recently, the last couple of weeks, we had some blowing dust across I-90 near Ritzville that caused an accident on I-90. These other pictures of the walls of dust were back from 2015 when we had at least 3 dust storms that moved through our area. The term for dust storm is also called haboobs, especially when they come from thunderstorm outflows. So any types of reports of blowing dust and reduced visibility, we'd like to hear from our weather spotters. Lightning is a main hazard for thunderstorms. All thunderstorms produce thunder and lightning. We don't have a list of lightning on our checklist, but just keep in mind when you see frequent lightning, it usually means that the thunderstorm is intensifying and getting strong to severe. But if you had any type of lightning damage or a lightning strikes a tree or a building, we would like to get that information from any type of damage. Also want to keep in mind to be safe around thunderstorms and show how the lightning develops in a thunderstorm. As the cumulonimbus grows and develops rapidly in the atmosphere, it causes charges, electrical charges within the storm to separate, with positive charges migrating to the top, the anvil of the storm, and negative charges remaining near the lower part of the thunderstorm. The charges don't want to remain separated. They want to merge and discharge, and that's what causes the lightning to develop in the thunderstorm. But keep in mind, if you are out during a thunderstorm and not in a safe place, you want to be alert to signs that lightning is about to strike. So be safe, and you don't want anybody's hair to stand on end because that's a sign that lightning is about to strike. So be safe, go to a safe location in your house, in your vehicle, and wait at least 30 minutes until a thunderstorm leaves your area. So personal safety is number 1. Be aware of the weather in your area, have good communication, know an escape route if you get stuck in an area, and know where your safe zone is. It's very important to be careful at night when visibility is reduced. And remember, don't drive through flooded roadways, don't travel through down power lines, and don't be too near to fallen objects or structures. Keep safe and keep alert on the weather. So how do we get the word out that it's going to be a thunderstorm day? Well, we have other offices in the National Weather Service that do help the local offices get the word out. One of it is the National Storm Prediction Center in Norman, Oklahoma. They look across the whole country and identify areas of thunderstorms. You can see them at this webpage, spc.noaa.gov. And it allows you to, you can look on your own and see where the thunderstorm hotspots are each day. They also work with the local offices to get the information out on the types of thunderstorms that are expected each day. And they will rank the risk categories depending on the severity of the storms that they are experiencing, ranging from general thunderstorms to marginal risk of severe weather to a slight risk of severe weather, which means there could be some scattered severe storms possible, to an enhanced risk, to a moderate risk, and the highest point would be the high risk. And those are the days that you would be seeing tornadoes in a certain area. So the National Weather Service also has terminology to describe the components of the storms and what type of products need to go out to warn the public of these types of severe and significant storms. When we see an event happening that's several days out and our confidence is about, we're feeling pretty good that we're going to see some thunderstorms developing, we'll be issuing an outlook, a hazardous weather outlook, to alert the public that we see the potential for thunderstorms. When we get within a day or so and we're thinking that there's going to be thunderstorms, we're going to increase our confidence, and with the help of the Severe Storms Forecast Center, issue a watch for severe thunderstorms. Typically, this goes out a few hours before we're going to see these storms develop. And this is to let you know conditions are favorable for severe weather, but it's not happening right now, just to give you time to get ready for it. When we issue warnings, that means severe weather is happening or is about to happen in your area, and you should take cover when you hear a warning has been issued. Now, for some of our significant weather events, sometimes we'll issue warnings for events. Other times we'll issue an advisory. And what an advisory is to let you know that their weather event is occurring, but it's not considerably severe. What we're going to be seeing is nuisance type weather or flooding happening. That will probably just cause a little more inconvenience, but not a loss of life or property. We have quite a list of different types of weather warnings that we issue from our office. Those highlighted in orange would be considered our short fused warnings. So those would be considered with thunderstorm events. That would be flash flooding, severe thunderstorms, tornado warnings. And the decision to put them out happens rapidly, and we send it out through our communications venues and alert on NOAA radio. The ones in blue would be considered our long fuse warnings. We usually issue these during our colder times of the year with winter weather, with windstorms, with fire weather, and even for freeze warnings. And these usually take a few hours to evolve, but they can be just as significant. All right, so we're ready for the next poll question. And this is one to think about a little bit. After you learned a lot about the thunderstorm safety and between watches and warnings, what do you think you would do if you see some lightning on the horizon and you hear a severe thunderstorm warning is issued for your area? What would be the correct option to do in this example? I'm going to let you mull it over and answer those questions. Okay, I'm going to look at other questions and try to answer them online. Here's one that says, if hot air rises, why do temperatures get colder as you go up in elevation? Oh, that is a good question. So hot air, yes, it does rise. It is less dense. It wants to rise. But as it does, the air parcels will cool as it rises through the atmosphere. So there is a cooling process as it goes up, as you go up through the atmosphere. Let's see if there is other questions. Okay. Oh, wow. It looks like most of our collection is done with the polls, and it is looking really good. So let's give this a close and we will share it with the group. Well, majority says get your family safely inside. If you see lightning on the horizon and hear a severe thunderstorm warning has been issued for your area. That is a very safe and smart thing to do, even though it'd be really cool to stand outside and watch the storm come. The safe thing to do would be to go inside. So great job on that. Well, as I was saying, there are many ways to stay informed. We have NOAA Weather Radio that gives up-to-date weather information on forecasts, current conditions, and will alert you if there is warnings for your area. And this is a radio broadcast that comes right from our Weather Service office. There is an automated voice with that, but it will alert you when conditions warrant for severe weather. And it's really handy to have, especially if you're going to be out camping or hiking or traveling. If you can pick up the signal of the closest transmitter, you can get the NOAA Weather Radio broadcast. Another great way to stay informed is through our webpage, weather.gov/Spokane. And on it, you can get a wealth of information. I was sharing with you ways to look at satellite data. You can get radar data. You can look at our upper air soundings and observations. And also, you can get to the page. There's usually going to be some type of a weather story with a picture, an image on the top part of the page. If you scroll down, you will see the map of our county warning area that highlights the counties and the zones for our area. And you can click on the map and you can get a forecast, a detailed forecast for that location. So we'll click right on Spokane. I'll tell you what the current conditions are, the 7-day forecast, and you can get the information you need on that. The other thing with that map is it will be highlighted in different colors when we have different types of weather watches and warnings out for our area. And another way to stay informed is right from your phone. So the National Weather Service does not have a weather app, but there's a way that you can get a widget right on your phone to get updated National Weather Service forecasts. All you need to do is go to your internet browser on your phone, type in mobile.weather.gov, and from there you put in your location, Spokane, Washington, Sandpoint, Idaho, Odessa, Washington, and hit go, and you'll get the forecast that looks just like what's on our Weather Service webpage. And then what you can do is go to the bottom of your phone and add the website to your home screen. And that will make a widget on your phone that you can go back to and see the forecast and get your weather data. So very handy to have. So we have talked quite a bit about thunderstorms, about severe weather, about the National Weather Service, and what it takes to be a weather spotter. So we have covered the bulk of weather spotter training, but I wanted to share with you other programs, other networks that are available if you want to get involved even more. So one that I want to talk about is the Community Collaborative Rain, Hail, and Snow Network. I know that is a mouthful, and we kind of shorten it down to an acronym and call it COCORAS. This is a partner network that works with the National Weather Service, and what their goal is to increase the precipitation measurements across the country. And you can join in as a volunteer. You just go to cocoras.org. You can learn about the program and you can join right on that webpage. And what it allows you to do is to report precipitation measure it and report it right through this web page. And also, if you are not one of those observers, you can still use the data, click on a state or a county, and find out precipitation amounts each day on this site. So rainfall measurements, what does that mean? Well, first you will need to get a rain gauge. And this would be a standard 4-inch rain gauge, and you can order them on weatheryourway.com and they can mail them to you. And you post it outside, set it up in an open area away from trees and shelters and buildings, so it's in an open area. And then every day you go out and read your rain gauge. And it even explains how to read the water line and up to 1/100th of an inch of precipitation. And then you go to that web page and you report your rain. So it's very easy to do that. When we get into the winter time, it gets to be a little more involved, but it's very useful data because this is where you get to report snowfall, the amount of new snow that falls. You want to know how much water is in the snow. So you actually take the rain gauge inside and melt down the snow and find out how much water is in the snow. And then there's measurements of the snow depth, which is the old and the new snow together and how much of that is on the ground. And that is all entered on that web page. So really important data and very valuable for weather forecasters to know how much snow has fallen, how much rain has fallen. Even if it's been dry, we still want to hear those reports. Those zeros are very important. And we have weather inland Northwest CoCoRaHS observers all across our region. We have over 100 active ones that report in their precipitation each day. So we welcome new observers as well. Another program I want to share with you is called the Citizens Weather Observers Program. This one acronym is a CWOP, and you can go to this web page, which is wxqa.com. And it's for those of you that have a weather station, that you've invested the time and energy and money in a weather station, and you hook it up to your computer. Well, now you can take that data and share it online. And a lot of different weather enterprises could use that data, including the National Weather Service. So with those that have a PC and an internet connection, you just hook it up and get a weather ID, and you can share that data with other weather enthusiasts. So these are all 3 different programs, all useful to the National Weather Service. It just depends what you are interested in. So keep in mind, Weather Spotter program, they report severe, significant weather. There's no weather instruments required, just your eyes and your ears, maybe a ruler. But pretty much it's just what you're seeing is what you report. It's all event driven, and you sign up by joining one of these courses or emailing the National Weather Service. The CoCoRaHS program is precipitation only, and it's a daily commitment, and you need to get a rain gauge and measure it every day. And you send in your reports and register at cocorahs.org. The CWOP program involves a little bit more. It's for those that have the weather station. You gather the weather data, you hook it online, has a daily commitment, and you go to the wxqa.com to register for that. All right, so one more poll question. Just need to know what you think about these different programs. Would you be interested in additional weather programs, or would you just be happy to be a weather spotter? Just kind of gauging this information because I can help you with all of those programs. All right, we'll see if there's any more questions that came up. Oh, there is a few more. All right, how is the XX% chance of precipitation determined in a forecast? Well, that is a good question. That XX, that number, is giving us the confidence of a measurable precipitation, so at least 1/100th of an inch falling in a rain gauge. And we base that off of looking at weather models, what our confidence is, and if we think that it's going to be a light event versus a heavy precipitation event. So it basically comes down to the observation and the forecast data on the probability of precipitation. Another question is more about NOAA weather radio. Can you change the voice on the automated weather radios? It could use some variety. Well, I agree. I think we have different voices. We have switched them around in the past. Maybe we have to look at doing that again. Can you tune into NOAA weather radio on regular car radios or via a phone app? Well, I believe there are some phone apps that you can listen to NOAA weather radio and pick a transmitter in a certain area to get the data from. A regular car radio, it needs to have the weather band. And I know I had an old Subaru that used to have that, and I thought it was great that I could hear NOAA weather radio. There may be other cars that have it. You just need to check to see on your car stereo if it's available. Other questions. Why do the storms coming from the west break around Coulee City to Elmira and go either north along Lake Roosevelt or south along I-90? Well, it has to do with the track of the storms and the terrain. I would think it's mostly having to do with the terrain and how they're moving into an area. We have many microclimates across eastern Washington and North Idaho, and I hear these stories from weather spotters and observers that tell me how storms track around certain locations and will hit one area and not another. So a lot of it has to do with the favorable winds and what the terrain is doing. And another question having to do with our zone map. Why does Spokane weather zone bulge into Lincoln County? Well, as I mentioned, it has to do with the climatology around the area. And we found that the West Plains of Spokane the climatology extends into Reardon toward Davenport. So we kind of included that area in our Spokane zone. So very good questions, and I'm going to close the polls and share that data. Looks like we have some people that are interested in precipitation measurements and the online weather stations. So if you want some additional information on that, please reach out to me and I can help you with that information. So great. Wonderful. Okay, so we'll move on our web page. We have a link for spotter resources online that you can get additional spotter training information. You can see past spotter training videos, the sign-up form, the checklists, and our latest newsletters that can be available for your viewing. Also, if you want to learn more about weather spotting techniques, more about thunderstorms or anything weather related, there's a great source at the METED website where you can get over 300 free weather classes that you can learn about all different types of weather. And if you have the time and interested to learn more, I highly recommend that to see these classes. And I want to congratulate you. You have now completed basic weather spotting. And thanks for sticking with me this evening and covering this material. Here's a copy of the Weather Spotter certificate that each one of you will receive for completing this course. And it will include your spotter ID as well. So I want to thank you for joining. Remember that toll-free number, 800-483-4532, to call in your reports. If you have any questions, there's my email, robin.fox@noaa.gov. And I will open things up for questions because I'm wondering if there are any more that will have questions for me. And if you like, I can have you talk online as well. We can open that up. If you just want to raise your hand, we can have some questions to talk about. Or I can just read some that came through right now. Okay, here's one. Answer via email. Transponder frequency of balloons. Oh, well, yes, we do have some certain frequencies to send our weather balloon data on. And I don't know the frequencies off the top of my head, but I know that we set those weather balloons to certain frequencies. Let's see. Yes, if you want to add any family members who also listened to this weather spotter training, yes, please do. I will be sending out emails, follow-up emails, probably in the next day or so, to gather your contact information. So look forward to that. And if you want to include any of your family members, please let me know. Can you repeat the way to get a tone alert phone app? Well, the best way to get your weather forecast data is at mobile.weather.gov. And that will be the easiest way to get the National Weather Service weather widget on your phone. And you can get that data. I know there are other apps, third-party vendors that you can get NOAA weather radio broadcasts. Also, on some of our short fuse warnings like tornadoes or flash floods, and even dust storm warnings, we can send out, when we send the warnings, it will send out a wireless alert that will alert phones if you are in the area of that warning. So if there are short fuse emergencies that we need to notify people, that's another way that we can get the message out. Okay. All right. If you are a current weather spotter, I will still email you just to make sure that everything is current. But if you haven't moved, you will keep your same spotter ID. I just like checking in and making sure there hasn't been any changes. But for those new to the program, we will sign you up with a new weather spotter ID. Okay. Remember, if you have any other questions, let's see. Let's see if we have anybody that, I see a couple hands raised. Let me just see if anybody wants to talk. I hear. Okay. All right. Not seeing anybody that wants to talk right now. If you want to just type in a question for me, I'm happy to answer it. Okay. Great, great, great.
Okay, can you hear me now?
All right. Any links to weather stations? Links to weather stations. Yes, on our webpage, we have links to many different current conditions right on the maps, and that would be under our current conditions tab under observations, and you can see those links. To just click on the weather station link and it will give you additional data for that.